Okay, so before we run into the past paper questions, right? So what are we going to do is we are going to talk about two of the theories that is going to be helpful for us in doing questions, right? So these are going to be technically how do we write? Okay, so how do we represent sine and then cos in terms of what we call as half tan angles, right? So let's see. Right, so suppose that we are given sin x. Okay, so what can I do is I can write this in double angle formula. So I can write it as 2 sin x over 2 cos x over 2, and afterwards I can think, okay, so I can I have 1 underneath, which is true, right? I mean, I can write 1 under pretty much any number and it doesn't do much. So this is what we have. Now what is going to happen is I can imagine that the 1 is actually the square of sine squared x over 2 plus cos squared x over 2, like that. Now afterwards, it's clear that we can divide both the numerator and the denominator with cos squared x. Like this, and then we have sine squared x over 2 divided by cos squared x over 2, and we have here cos squared x over 2 divided by again cos squared x over 2. And now what will happen is that one of the x2, this cos x will cancel off, and then here the cos squared x over 2 to cos squared x over 2 completely cancels off, leaving us here with 2. I'll write it up here, which is going to be equal to 2 sin x over 2 over cos x over 2 divided by, which is going to be this part, right? So sine squared x over 2 over cos squared x over 2 and plus 1, because the cos squared x over 2 to cos squared x over 2 basically cancelled off. So here sine over cos is technically tan, so we write 2 into tan x over 2 divided by, here we will be getting again tan squared, so this is tan squared x over 2 plus 1. So this is the representation of sin x. Okay, so you can write sin x as basically half tan formulas. Okay, so that is very easy. Afterwards, we need to write a cos also the same way. So I'm going to erase this. You guys can write it. I guess I know you guys can write it. So for the next one, say that we have cos x. So similarly, you can write this thing as cos squared x over 2 minus sine squared x over 2. Now if you want, you can pause the video and then work it from here just like the earlier one. So I can divide this by 1. So 1 is technically cos squared x over 2 plus sine squared x over 2. And just like the earlier one, I'm going to divide both the numerator and the denominator by cos squared x. So I have to divide this. I'll have to divide the other term also. So I need to divide this. And plus. So you can clearly see this and this cancel off. This and this also cancel off, you are going to basically have here, that's 1 minus, this is going to be tan squared x over 2, and 1, this is plus tan squared x over 2. So that completes the for the formulas for sine and cos in terms of what you call as tan half angles, right? So we'll move on with the some of the past paper questions. These are ancient, but I decided to take them for the discussion because I felt these are good starting point for you guys. Hari. So I'm going to start with the paper question 1990. Now we are not, these are not full questions actually. These are going to be parts of the question that I've taken related to what we were doing so far. That is technically the inverse functions problems, right? So 1990 A levels, they had a question like this, and then sine inverse x equals to pi over 6. Okay. Now this question is a bit different than the problems we done, but I think it's related to one of the questions we did from the tute. So we want to solve it. We need to find what is x. That's the idea. So one can say something like this. You know, you can consider. Okay, so cos inverse of x is equal to alpha, and then you can consider that sine inverse of x is equal to beta. So technically alpha minus beta is equal to the pi over 6. So okay, so we have that, and then we can clearly say that x is equal to cos alpha, and then we have x is also equal to, now here we have sine beta. Okay, so we have things like that. Now what's going on? You can ask certain questions like this. So sine and cos have been both the same value. You can ask when would this happen. Okay, so anyways, if I were to get the range of the cos, so the range of the cos would be from here to here, right? So that's going to be the first and the second quadrant. And when it comes to the sine, the beta, the range of that is going to be from the fourth quadrant to the first quadrant, like that. Okay, so these are the range of the angles that we can use. So you can have angles measured in these things. Now as you can see, the x is same for both. That means if cos alpha is plus, sine beta must be positive as well. Okay, so that means, what does that mean? That means the alpha could be in the first quadrant, and this one has to be in the first quadrant as well. Otherwise what must happen is that if this is minus, that has to be a minus value as well, because it's the same thing, right? X and x, no? So cos alpha is the same as sine beta. That means their numerical values are the same. So which means if he is negative, he has to be in the what you call as a second quadrant, then the beta must be in the fourth quadrant. Now you have to then logically ask a question. So imagine, just imagine if an angle is somewhere here and the other angle is somewhere here, like that. Will that difference be ever? Okay, so the difference in the sense, like, you know, like this difference, can that ever be pi over 6? Pi over 6 is basically 30 degrees. It's impossible, right? So that is going to form anyway what you call as angle larger than, the closest values are here and here, and that is also 90 degrees. So that is not possible, right? So that is not possible. So that means x has to be both positive. So we'll conclude that, right? So you have to conclude that x must be positive. It's impossible they are going to be negative. Now what is going on is, then since it's positive, that what does that mean is that angles are going to be acute angles. So I'm going to rewrite this. Sine beta is equal to cos alpha. So you can do it like memorize and do these things, but Don't do so, like think carefully. And also if the angles are in these quadrants, yeah, then it's possible, right? Then it's possible to have the difference into be 30 degrees, and this is the first same quadrant. If they're in two different quadrants, the difference of those two angles is impossible. The gap is 30 degrees. 90 degrees possible, but not smaller than that. So that's cos x has to be positive. Okay, so then we can write sine beta is equal to cos alpha. So then I can write like this. So cos, this is pi over 2 minus beta, right? Because the acute angles, we can easily write it like that. Now what's going on? Then both are the same, and acute angles, we don't have to look for any general solution type equations, because they're acute. They are what they are. And then you can write that alpha plus beta. That's by moving the beta to the other side. So beta goes to the other side. I'll write it like that. Beta goes to the other side and becomes positive. Alpha plus beta. Right? So that's equal to pi over 2. So we have two equations. One equation is this. So let me put this in a box. One equation is this one. And this is my second one. Harry. That's my second one. So now what is happening is I have to solve and find alpha. So if I find cos alpha, then we got x. Okay, so just find alpha. So I can add those two together. Okay, so 1 plus 2. If I add the first equation and the second equation, but hurry lazy. So alpha plus alpha is going to be 2 alpha. Hurry. And then there's minus beta, and then there's plus beta. So they cancel off and gives us basically pi over 2 and plus pi over 6. Now what is going to happen from here? It's clear that 2 alpha is going to be equal to, that's 3 4 pi, no, 4 pi over 6. So then alpha is going to be so that's 2 pi over 6, so pi over 3. There you go. So we found the value of alpha has to be pi over 3. So since that is the case, we can write that cos pi over 3, as you can see here, is the x. So x is going to be equal to half. So that completes the problem. Okay, so that's the problem from 1990 A levels. So understand the concept properly, think carefully before you do any questions. Okay, so that's how you work on the problem. You can copy it down, obviously. Pause it. So we are going to move on to 1991. Yes. We'll do some modern problems as well. So in the 1991 A levels, the question says something like this. It says tan inverse y minus 1 over y minus 2, and then plus tan inverse, we have y plus 1 and y plus 2. You have to show that it is equal to pi over 4. My bad, not show, but it is equal to pi over 4 indeed. You have to find out what is the value of y. Okay, so you guys take like 10 minutes to try the problem out on your own. Now we have done several questions. You can use one of the strategies. Okay, so pause the video, try it on your own and come back quickly. Hi. So I hope you guys have tried something now after pausing. What am I going to do is I'm going to consider this as alpha. This is basically beta. So alpha plus beta, right? Alpha plus beta, I will say is equal to pi over 4. Now what happens is I can take tan alpha plus beta on both sides. Okay, so that's tan alpha here. Tan pi over 4. So tan pi over 4 is 1. And this is going to be tan alpha tan beta 1 minus tan alpha into tan beta. Okay. Now we need to substitute what is tan alpha, tan beta likewise. So as you can see here, alpha is equal to that. So what does that mean for tan alpha? Tan alpha is what is inside the value y minus 1 and y minus 2. I'll write it over here. Alright. So I hope you guys can understand that, right? So what do I mean by this is we have alpha is equal to this, right? So alpha is equal to tan inverse of y minus 1 y minus 2. So y minus 1 over y minus 2 is equal to tan alpha. So you can substitute that for tan alpha. That's what I meant. So the tan alpha is going to be y minus 1 over y minus 2. That's tan alpha. And then I have plus tan beta. So I can do the same with that, which is y plus 1 divided by y plus 2. Then we need to divide this with 1 minus tan alpha into tan beta, which is going to be equal to y minus 1 over y minus 2 times y plus 1 over y plus 2, and this all of this is equal to 1. Okay, so that's the idea. Now I need to simplify the numerator. So I will be getting here y minus 1 y plus 2 plus y plus 1 into y minus 2 divided by y squared minus 4, and in the denominator you will be getting y squared minus 4, and then we'll have minus y squared minus 1 over y squared minus 4, right? So what is going to happen is these two will cancel off. Those two will technically cancel off. I believe we don't need this side now. I hope you guys have copied, or else you guys can scroll back. So what I can do is I can simplify the other things. So I can multiply y minus 1 into y plus 2. So that is going to give us y squared plus y minus 2. So if you guys can't do it in your heads like that, may do it and see, right? Multiply brackets one by one. So I'm going to do it in my head. Next bracket is y squared minus y minus 2. And then these two are cancelled, no need of them. This is what we have now, which is y squared minus 4 minus y squared plus 1. Okay, so how did that come? Y squared minus 4 you can write as normal, minus y squared, minus into minus is plus 1. This is equal to 1, by the way. So cancel what's getting cancelled, and then the y square also gets cancelled off this. So y squared and this y squared add up to 2y squared. Minus 2 is minus 4. And this is minus 4 plus 1 is minus 3, multiplies to the other side. So you can take the 4 to the other side. So y squared is going to be equal to 1 over 2. Then y is going to be equal to plus or minus of square root. You can say 1 over square root of 2. Okay, so both the answers are, both the values are possible for y. Okay, so that's very easy. Now so that is the question from 1991 A levels. Now moving on with the next one, 1992 we have. So in the 1992 A levels, they have given us tan inverse of x and then plus tan inverse of 2x is equal to pi over 4. We need to work out what is the x again. So I'm going to take a similar approach here. So I will consider this as alpha, and then this is beta. So what does that mean is that tan alpha equals to x, and then tan beta is equal to 2x. If you want, you can equate it here. Okay, so you can put and then start working from there. That's okay. But I have here now alpha plus beta equals to pi over 4. So we can take tan on both sides. So tan pi over 4. And then we can see tan pi over 4 is equal to 1. So this is going to be tan alpha plus tan beta over 1 minus tan alpha tan beta. Okay, so we can work the problem out like that. Now what is going on? Now the next thing we need to do is that we need to substitute the stuff. So you can see that tan alpha is equal to x and tan beta is equal to 2x, and then we have 1 minus, so this is x, this is 2x, so that is 2x squared. This is equal to 1, so you can cross multiply. So 3x, okay, x plus 2x is 3x equals 1 minus 2x squared. Take things to one side. So you have 2x squared plus 3x minus 1 equal to 0. So we need to solve this one. So either you can do completing square, so use a formula. So I'll use the formula here. So it's minus 3 plus or minus b squared minus 4ac. So b squared is 9. Then plus 2 times 4 is an 8 over 4. So x is going to be equal to minus 3 plus or minus okay, so they are like plus or minus, this is going to be root of 17, okay, square root of 17 over 4. Now the thing is, when you look at this question over here, you can see this alpha and beta is adding up to pi over 4, right? So it's adding up to pi over 4. There is no possible chance where any of them, I mean, if if this is a negative angle, because if you now think, right, so you have to think now. So cos angles are in this range, right? Angles, sorry, not cos tan is in the first and the second one. Right? So if they are positive, that means they are acute angles, acute positive angles. If they are negative, they are negative acute angles. So if one is negative, the other one is also going to be negative definitely, right? Okay, so if alpha is negative, then beta has to be negative as well because it's related to 2x. It's related to 2x. Then what does that mean? Is that it's never going to add up to a positive pi over 4 angle. So we have to ignore the negative case, right? So we have to write, but alpha beta is acute. So what is going to happen? We are going to only consider the positive case of this. So x is going to be equal to minus 3 plus square root of 17 over 4. So I can guarantee that root 17 is more than, it's larger than 3 because 16 square root itself is 4. So it's larger than 4, so larger than 3. So that's how you can work out the question from 1992 related to trigonometric inverse functions. And the next one, this is 1993. So I picked some, like questions from 90s. So you guys can observe the trend of how the questions back then was and how the questions change now. So we'll observe how the generation gap has caused whatever we are going to observe now. So in this one, what we have is we got tan inverse of 1 over x minus 1, and minus we have tan inverse of 1 over x plus 1. This is equal to tan inverse of half. Okay, so that's what we have. This also I can do the same way. So I intend to solve it like that. So this is going to be alpha minus beta. I'll say this is equal to gamma. So we'll take tan on both sides. This is tan gamma. Then this is going to be tan alpha minus tan beta over, we can say this is 1 plus tan alpha and into tan beta. This is equal to tan gamma. So tan gamma is actually equal to half because that's what it is. So tan alpha is equal to 1 over x minus 1 minus this is 1 over x plus 1 and 1 plus you will have 1 over product of these things which is x squared minus 1. So I'm going to cross multiply the denominator to the other side if I wanted to, but I will just simplify this one. So I need to multiply this one with x plus 1, right? So that is going to be x plus 1 for me, and then minus this 1 over here will be multiplied with x minus 1, and I will have x squared minus 1 in the denominator, and then this 1 has to be multiplied with x squared minus 1, which is x squared minus 1 plus 1 over x squared minus 1. This is equal to still half. Very easy. Now what is going to happen is you can simplify. So minus x, this cancel, minus minus become plus, that's 2. So 2 over x squared minus 1 divided by these two cancel, x squared over x squared minus 1 equal to half. So I'm going to take this space over here, utilize neither. So what will happen is these two cancels off because the division, I will have 2 over x squared equals to half. So cross multiply will do this one here, this one there. So then x squared is equal to 4. Then x equals to plus or minus of 2. So this don't give any conditions. So we can take both the answers correctly. It is allowed because the domain of tan is going to be, yeah, it's going to be pretty much anything, Harry. Okay, so that's what it is. So that's 1993. I hope you guys are pausing these things before you work them out, right? So when I write the question, pause the video and then try to solve it. That's what I'm saying. Going to 1994. So 1994, we have cos inverse of x squared minus 1, x squared plus 1, and then we have plus, this is tan inverse of 2x over x squared minus 1, and that's equal to 2 pi over 3. So in the question they had already said that this x is something larger than 1. Okay, so that's basically positive. Now looking at this, then when you look at these things you can see something, there's some pattern is there. Look at this value. So if you had tan alpha, so say tan 2 alpha, you can see this to be technically 2 tan alpha over 1 minus tan squared alpha. That's what you can see. Then in that case, you can see this has the same thing. So it's like 2x, 1 minus this is x squared. Except there's a small problem. The problem is technically here you have x squared minus 1 instead. So what you could do is you could put minus to both sides. That means you can multiply both sides with minus 1, and then you can write it like this. There you go. Okay, so that's 1. And on the next case I can do the same with this guy, because notice in the beginning of the video I said that cos 2 alpha or else cos alpha you can write in terms of half of tan. So this is going to be basically 1 minus tan squared alpha, and then this is 1 plus tan squared alpha. Okay, so that's what I explained. Then you can see here also just one small problem, that is here you have tan squared minus 1. Here you have 1 minus tan squared. So I can multiply both sides with minus 1. So I can convert it into the form that we need. Okay, so we have something like that. Now what's going on is I can take these things and substitute into that position. So what do I mean by that is I can instead of uh, so instead of this I can write it as minus cos 2 alpha. All right, and then what I can do here is that we have tan inverse. So we have tan inverse and we can write minus tan 2 alpha. Okay, so what have we done here is technically I have considered the x to be tan alpha. Okay, so we have considered x to be tan alpha. I'm going to erase this. You guys can play the video whatever the order you like. Okay, so here we have taken x equals tan alpha. Okay, so there's a pattern. You need to see the pattern. You might not see the pattern initially, but when you do a lot of questions and you practice a lot of questions as we go ahead, you will start to realize those things, right? So you're just starting, so I'm helping you guys out. Now the thing is I can't take just cos inverse of this, because there's a one problem is there's a minus value as well. So then I have to ask myself the question, why have I obtained a minus sign and how can I change it? So I can think of the problem like this. We know for sure that we are going to get a minus value for cos if the angle is in the second quadrant, right? So we know that we will be getting minus value for cos if it's in the second quadrant, and for the tan we know if it is in the in the quadrant in the back. So I will be writing this like this: cos, I can write this one as pi minus 2 alpha. So when I do this, this is going to be, okay, so cos, remember, pi minus theta is going to be minus cos theta. Okay, so I can get rid of the minus using this method, and then afterwards I will be having here tan. Now I need to deal with the minus sign of the tan as well. So how can we do that? So to deal with that problem we can understand that the angle of this one is in the second quadrant, in the sense sorry, not the second, the fourth quadrant. Okay, so we have taken the angle here like a minus 2 alpha. So then it's going to be minus, because this is going to be the range of the angles in the tan inverse, right? So this is going to be tan minus 2 alpha. So if I work this one out now, so we are in the range properly. So I can write this one as pi minus 2 alpha, and then that is going to be again minus 2 alpha. Alright, so we can remove the tans, alright, basically by the inverse function. And here you have 2 pi over 3. Addition of these two are going to be minus 4 alpha. So I can move the 4 alpha here and I can start working out what is the alpha. So I will work from there. I'm going to erase some of these things. I need space. So I have 3. So that's pi over 3 equals 4 alpha. Then alpha turns out to become pi over 12. Okay, so that becomes pi over 12. So then x will be one of the x values will become yes, tan pi over 12. So which is a valid answer because pi over 12 is an acute angle and tan pi over 12 is a positive value. So that satisfies the x. Okay, so that's going to be our answer. So that's 1994. Forgot to write it. Okay, so 1994.